Hey everybody, hope you're doing well. In this video, I want to talk about an algebraic limit in dealing with infinity. So here's the problem that I want to kind of look at. I have a limit as x goes to infinity of some rational function. And this rational function, the numerators are quadratic and the denominator is a quadratic. So what I'd like to do is talk about two limits that are going to be very, very helpful for this particular problem. The first limit that I want to talk about is a limit as x approaches infinity of 1 over x. And then I want to talk about the limit as x approaches infinity of 1 over x squared. So in order to do this, I want to show you some graphs. So what I have here is a Mathematica file, and I haven't evaluated anything. So I'm going to define f of x to be 1 over x, and I'm going to plot this function. So when I do this, I hope you see that as we move to the right with our x values, the y values are getting smaller and smaller. In fact, when I plug in 1 over 100, I get, well, 0.01. If I make this number even bigger, well, what you're going to see is these numbers on the left-hand side, they're going to get smaller and smaller. So what do you think the limit when x approaches infinity of 1 over x is going to be? Well, from our graph, I think we should conclude 0. Another way to think about this is 1 over a large number, and then 1 over an even larger number, well, that gets smaller. So I know I'm not going to get a negative number, and 0 is my best bet here. Now, what about 1 over x squared? Well, what's going to change here? If I go to this Mathematica file and I put in a square in here, take a look at the graph when I evaluate this. The y values get even smaller, but they're still positive. So what does that tell me? It tells me that this is also 0. So these two facts that I have on the right side of the page here are going to be very, very important for us. Now, why is that the case? Well, we're trying to plug in very, very large numbers here. And what I can do is I can algebraically leave this the same, but modify what it looks like. So what I'm going to do is I'm going to multiply top and bottom of this rational function by 1 over x squared. At this point, you may be going, why did he pick that? Well, let's just go through this problem and maybe you'll discover why I'm picking this. So when I multiply this out, I'm going to have 3 multiplications in the numerator and 3 multiplications in the denominator. I haven't done anything with the limit yet. So let's multiply this out. 3x squared times 1 over x squared. That's just the 3. 5x times 1 over x squared is 5 over x. What about negative 17 times 1 over x squared? Well, that's 17 over x squared with a minus sign in front of it. And in a very similar fashion, I can do the bottom here. 381 over x squared. Now, what's one nice thing about limits? The limit of a quotient is the quotient of the limits, provided it actually produces a number and the denominator is not 0. So I have 6 limit problems here. And the 6 limit problems, problem number 1, 2, 3, 4, 5, and 6. So I'm not going to write down every single limit here. But what I want to do is write down the answers for each one of these. And I want to give you a rationale. The limit of a constant is that constant. Now the limit of 5 over x, well, I want to think about this over here. If I multiply this by 5, does that change? No. because 5 times 0 is still 0. And in a very similar fashion, the answer to number 3 is also 0. Because if I multiply this by negative 17 times 0, well, that's still 0. Question 4, well, that's a constant of 7, so I'm going to write down a 7. And for 5 and 6, it's very similar to 2 and 3, and I wind up getting 0 and 0. So my answer after I take the limit is 3 plus 0 minus 0 over 7 minus 0 plus 0, or 3/7. So this is one example of a limit where x goes to infinity of a rational function. So what was that question I had in the beginning? Why did I choose 1 over x squared? I want you to look at the numerator. What's the degree of that polynomial? The answer is 2. And the degree of the denominator? The answer is 2. They're both exactly the same. So that's why I want to be using 1 over x to the second, or 2 power. And that's why I chose this particular odd way to write the number 1. 1 over x squared divided by 1 over x squared. So I hope this infinite limit, well, it was 3/7. X was going to infinity, but the limit itself was 3/7. I hope that was helpful. If you have any questions, let me know. Bye.